Okay, so our topic for today is Open RAN use cases. So the Open RAN use cases is the fourth and last topic for our technical training in the month of November. So let me just have a quick recap on this. Okay, so we started introduction to Open RAN last November 5, deep dive into ORAN architecture, and then we had this RAN Intelligent Controller. So sa deep dive, nakasama natin si Jocelyn Reyes together with Delina from Mavenir. And last week, we discussed about RAN Intelligent Controller, also delivered by Jocelyn Reyes. And together with DICT-AORA, no, from Bandung, Indonesia. So we had an experience how to access remote laboratory in DICT laboratory. Today we'll discuss about ORAN use cases. Okay, so the ORAN use cases, the topics for today is the ORAN technical priorities, parameters and thresholds, and then the ORAN use cases, traffic steering, QoS-based resource optimization, RAN sharing, massive MIMO beamforming optimization, and the flight path-based dynamic unmanned aerial vehicle resource allocation. So these are the use cases that we will discuss today. And I hope matapos natin siya. We complete it in time because a lot of topics and it depends. I'll just control the time. So we have 4 hours to do it. But on top of this, we will have a simulation exercises. So today also, I will ask you, after the ORAN technical priorities, we'll have a short break. And after we resume, we will have a simulation. So I will ask you to create an account in Cloud RF. And you will create your account and then we will try to do the simulation. So at the same time, especially for the university instructors and college instructors, it is important for you also to learn how to do some fundamental simulations, coverage simulations, particularly for LTE and 5G. Because when we try to discuss the Open RAN, so the radio access network simulations and planning will be included. And also to invite everybody and to also add the motivation for you to learn more about Open RAN. So we will have a certification, basic certification of Open RAN here in the Philippines, scheduled on January 2023. So if you are interested to join or to take the Open RAN certification on January 2023, so you still have time to study Open RAN and review what we have learned in the 4 sessions that we have delivered through the help of the ICT. Okay? Okay, are you ready to discuss the Open RAN? But before that, we will have warm-up exercises, okay, for Open RAN. So just to recap what you have learned. So when we do the recap, normally we do Kahoot. Okay, so let's I invite everybody to join and participate the Kahoot. So this is the link and I will post it in our chat. Okay, just click the link and then you will be directed to this Kahoot. So this is just a 10 questions only, just to recap what we have learned from the previous topics like introduction to Open RAN, RAN Intelligent Controller, and deep dive into ORAN architecture. Okay, I hope everybody will join. So we are currently 108 participants right now. So nasa kalahati pa lang tayo. Okay, I think this is enough for this exercise. So let's start. Okay, question number 1. Multi-select. Open RAN is an industry movement to develop disaggregated and interoperable radio access network solutions using what? What are the different solutions, different elements composing the Open RAN system? So we need to have a general purpose processor, software-defined technologies, and open interfaces. Okay, proprietary interface is not anymore part of the Open RAN system. Okay. Number 2, it is the radio access network that uses COTS or commercial off-the-shelf hardware, open interface, and proprietary software, multi-vendor. Proprietary software and multi-vendor and open interface. Okay, so this is Open RAN. So there's a tricky one, you know. So because the software is sometimes proprietary, but the main benefit is the hardware would be COTS and the interface is open. Okay, number 3. This group has created its own ecosystem of Open RAN with small cells mind. Small cell forum. Okay. Next, number 4. In ORAN Alliance, which working group focuses on all use cases and overall architecture of Open RAN. It's a work group 1, no? Yeah. Okay. Number 5. Who founded Telecom Infra Project in 2016? Who founded Telecom Infra Project in 2016? It's Facebook or Meta. Number 6. In this architecture, RRU stays at the cell site, while the BBU are aggregated into centralized RAN. Okay, number 7. Which element in the ORAN architecture has the following characteristics? It has a physical infra nodes to host the ORAN functions. All of the following functionalities will be hosted in this physical infra nodes. This is where you can locate the servers, hosts, call it the O cloud. Number 8. Which interfaces in the ORAN architecture are considered open? All of the above. All of them are open interfaces. Okay, number 9. Multi-select. What are the 2 main initiatives that support Open RAN? They are the first organizations or initiative. One coming from Facebook, the other coming from DICT-AORA and the ORAN Alliance and the TIP. Next, last one, true or false? Open RAN enables multi-vendor RAN solutions and allows optimizing each network component. Okay, so let's see the scores. Who's the top 3? Number 3 is JP. Number 2 is and number 1 is what's this? Body. Congratulations. You earned the bragging rights. Yeah. In our Kahoot for the day. Okay, so let's proceed now to our topic for today. So I hope everybody is refreshed about the topics from the first, second, and third sessions. Now we'll proceed with the fourth session. It's the ORAN use cases. We'll start with the ORAN technical priorities. Okay. So when we say technical priorities, so these are the different technical building blocks, no, that was prioritized by the European operators. When we look at it, it is subdivided into 10 major block requirements. So the following European operators are si Deutsche Telekom, si Orange, Telefonica, TIM, and Vodafone. Okay, so these are the 10 technical building block requirements. So like for example, the O cloud architecture. So they define that a Kubernetes-based O cloud platform supporting the necessary RAN software shall be the mainstream implementation when we implement the ORAN or the O cloud infrastructure. Next is the OCU and the ODU implemented as container network functions on power efficient and reliable general purpose processor CPU with hardware acceleration support for ODU processing. And then the ORU Ease of deployment and operation is key. So facilitated by multi-band RRUs and AAUs, both with low weight and high power efficiency. Open front hole, okay, and then main run features are focusing in the 4G and 5G, both based in LSA and SA. Okay, so non-standalone and standalone architecture. And the RAN intelligent controller should bring enhancements in the terms of intelligence and programmability, automation, and SMO. Vendor shall adopt a unified data and information model to increase service management efficiency. It also focuses on energy efficiency. Hardware should be the most energy efficient as possible, starting with the radio transmitters. Okay, so when you talk about the power saving, the radio access network is the most amount of power consumed in one cell site. So when we do the trial, it's almost reaching to 60 to 70% of the total power consumption. Of course, security, it's a global priority for the operators, requiring strict policies and features across all entities of the Open RAN network. So we will have a separate course on the security of Open RAN. So there is a dedicated or separate instructor about security. So as he mentioned, Open RAN is created with security in mind. Okay, because all the components would be open and it would be interoperable to each other. So security is one of the main priorities. And high availability. So the key requirement to ensure the expected reliability of the operators, networks, and services encompassing the domains of Open RAN. So these are the 10 technical building block requirements. If you look at it, there is a document that was created on this particular topic. So let me just open these two documents so you can browse it. I will just put it in our web portal so you can browse it later on. Buksan ko lang na saglit lang. Okay, so kapag na-open natin yung PDF file, this PDF file, so the PDF file contains information like this. So this the Open RAN Technical Priorities Executive Summary. Okay, so this is the memorandum of understanding between these operators. Okay, so when you look at it inside, so there's an objective, okay, the scenarios, technology spectrum, architecture, and then the technical building blocks, okay, about the O-Cloud, the OCU, ODU, ORU, the open front hole, the main RAN features, RAN intelligent controller, automation, energy efficiency, security, and the high availability. Okay, so these are these are technical documents that they have created. And along with this document is the summary of the ORAN technical specifications or document. So when you open that Excel file, okay, you can see this Open RAN technical priorities. Okay, so these are the details that you can see. So there is an intro. So in the intro, you can see, let me just make it bigger. Okay, can you see the screen? Kita niyo ba yung ating screen? Okay. So this is the definition of terms. So there you can see the release, okay, which release it's the latest release from this technical priority document. And then we have the priority levels. So the priority levels is divided into two. Priority 0 and priority 1. So priority 0 means must have or shall support. So operators consider that these technical requirements are the highest priority to support the development of the Open RAN ecosystem and Open RAN's deployment scenarios. We could say that it is a mandatory requirement or priority 0. No? Okay. And P1 is nice to have. Okay, so not necessarily, but could be considered as a feature. Nice to have in the system. So we have priority 0 and priority 1. And then we also have the priority type. The priority type is categorized into 3. Unanimity. So meaning all 5 operators have the corresponding priority. So meaning all of them agrees to have, like for example, all priority 0 or all priority 1. Okay, so unanimity. And then we have this majority, or 3 or 4 operators have the corresponding priority. And minority, 1 or 2 operators have the corresponding priority. So the latest version that I got is on June 2021, last year. Okay, so let's see the different scenarios of this document. So with this document only, you will learn a lot about Open RAN. Okay, so you can see the different scenarios. So the topics are subdivided into different topics and the requirement list, the description, and the priority. So the priority level or priority type. Like for example, in the macro distributed scenario, we have the scenario 1 and scenario 2. So support of ORU and ODU CU in non-VRAN, in which the equipment are located on site with open front hole. So this is the priority 1. And almost all of them are agreed that this will be priority 1. But for priority 2, they would like to have a support of ORU and virtualized DU and CU. So this is what they are prioritizing. So deployment of the virtual DU and VU and on-site and with open front hole. So they have, this one. They have the priority 0 and unanimity, meaning all of them agreed that this scenario 2 must be priority 0. Okay, so whenever there are vendors or manufacturers or software developers that will be participating in the Open RAN ecosystem, scenario 2 must be the first priority. Okay, so we have a different scenarios: macro centralized, okay, RAN sharing, MOC-N, okay, RAN sharing, MORAN. So most of them are not on unanimity, no? So let's just try to figure out which one or which of the following have this P0 and unanimity. Okay. Okay. For indoor, you can see for indoor and mono operator. So they have this scenario 15, which support for mono operator, 1 operator indoor small cell with virtualized DU and CU and open front hole. So it's just like the indoor version of the outdoor. Okay, the macro distributed. Okay, so this is also priority 0 and unanimity. What else? Let's see. For outdoor small cells. So for small cells, these are the small cell sites with low power, typically catering a hotspot area with high bandwidth. Okay. So support for mono operator outdoor small cell and virtualized DU and CU. So same, almost same scenario with indoor and outdoor. And yeah, so 16, that is 18. So when you look at the architecture, this is how it looks like. Okay. So when you have a macro distributed scenarios, you will have the scenario 2, right? So this is the one where they have unanimity and priority 0. So the ORU, the open front hole, and the VDU and VCU are located on site. Okay. So there's an infrastructure there. There's an edge cloud and edge regional cloud. Okay. So this is the scenario 2. Other scenarios like macro centralized. So this is how it is being planned to implement. Okay. So you can see all the scenarios that these operators are proposing or planning or prioritizing. Okay. This is the MORAN, the indoor scenarios. So they are mono operators. So they are looking at this. okay, at this scenario as priority 0. But they have different scenarios as well. No? So if there's a multi-operator, like for example, two or more operators would like to share an infrastructure, okay, so they could use also the scenario 17. Small outdoor scenarios are also like this. Okay, so what they want to do is this scenario 18. Okay, so this is the priority 0. Okay, so these are the different scenarios. And the different character or different specifications are here. So a lot. Okay, so if you like to get more, so if you are one of those like for example vendors or developers in each domain, so you need to have a good understanding on the description and what are the priorities. And also here you can see the ORAN reference specifications, where you can see the specifications. Okay, so for the O cloud, okay, and the CU and DU, okay, containerization. Okay, so this is the priority 0. Okay, so they want to have the CUDU to support containerization. Okay, ORU details are also here. So the ORU details, they just define the radio unit category. Like for example, if the vendor will manufacture like a single band RRU, what are the different frequencies? So basically, these are the major frequencies used in the industry right now. So whenever we want to use Open RAN, we will not use a different frequency. So we will use the most probably the existing frequencies of the operators. Okay, so that's why when they propose to have this technical prioritization, they input all the frequencies that they're currently using in their network. Okay, so you can see the single band. There is also a dual or triple band RRH. So meaning there's a combination of low band like 800 and 900. There's a combination of 700, 800, and 900 for the tri-band or the triple band. And there is also dual band, mid band FDD. So it's a combination of 1800 and 2100. There's also triple band. So 1800, 21, and 26. As you can see, there is few or no combination for the high band and the low band, no? Because probably the design in the circuitry, in the IC chips, that's why they cannot combine the low band and the high band. So basically, when you look at the RRUs, it's either low band combination of different bands in the low band and combinations of different frequencies in the high band. But the low band, high band is we don't have right now here in documentation. You can see also the transmit receive mode, if it's 2T2R, okay, or 44R, okay, or 4x4 MIMO or 2x2 MIMO. For massive MIMO configuration, you can see the 64T64R and 32T32R. Okay, so later on we'll discuss this in the massive MIMO. Maximum power also have IBW is the instantaneous bandwidth, and occupied bandwidth is this one, volume, weight, and technology. Okay, so these are the detailed requirements in the ORU. There's also ORU general, okay, open front hole. Okay, so these are the categories of open front hole. RAN features. So let's see the RAN features. So for the coverage, so we have the RAN architecture. Okay, so the RAN architecture must using the LTE EPC. The main node is the LTE and secondary node is the 5G. So that is the NSA, EU-TRAN NR dual connectivity. Okay, so these are the different options. There is radio interface, MIMO. Okay, so minimum requirement is 4x4 MIMO, 8x8 MIMO, and multi-user MIMO, and also there's a massive MIMO. Dual connectivity, carrier aggregation, ANR, and up to the slicing, and yeah, narrowband IoT, and LTE, IoT, and RAN sharing. Yeah, so these are the one that we will be discussing today. In terms of the RAN intelligent controller, so these are the requirements. Okay. RIC use cases. Okay, RAN intelligent use cases. Okay, so we will be focusing on the traffic steering, QoE, QoS, massive MIMO, RAN sharing. Okay, so these are the different use cases. And for the SMO, okay, so you can see the SMO. Okay, so under the OAM, operations and maintenance architecture, okay, it must support the interaction between the service management and orchestration framework and OCloud through O2 interface. So this is the fundamental, right? Because in the architecture, we can see this, that there is interconnection and interaction between the SMO and the OCloud. Okay, so these are the different technical priorities in the Open RAN technical documentation created by the 5 major European operators. Okay. Okay, so the next slide would just show the one that I have shown to you previously. So this is the technical preparation, technical priorities. Okay. Okay. So next topic would be on the parameters and thresholds. Okay, so parameters and thresholds. So under the parameter and threshold, we will be discussing about the different parameters and for you to visualize and appreciate how these parameters are being used in Open RAN, or not only in Open RAN, but also in the radio access network. I will show you, or we will use a simulation tool that we will use for providing a coverage map. Okay, so I will give you around 15 minutes of break time. And during the break time, you need to install this Cloud RF. So in your browser, you just put Cloud RF. Okay, you just use the Cloud RF. Okay, so this is the link. Nakita niyo yung link ng Cloud RF? I send it through the meeting chat. So you need to have an account dito sa Cloud RF. And then later on, I will probably on the next 30 minutes or 30 minutes or 45 minutes, we will study about this Cloud RF simulation. And then slowly, we will discuss the different use cases of the Open RAN. Okay, can you see the link? Nabuksan niyo yung link? Hello, can you see the link? Ayan, so access niyo yung link and then try to create an account para makasabay kayo dun sa ating simulation mamaya. Okay, so right now it's 8:50. So balik tayo ng 9:05. 15-minute break muna tayo. And then pag nag-resume tayo after 15 minutes, you need to have this in your laptop or in your desktop. And then mag-simulate tayo afterwards. Okay? Is that clear? Okay lang ba yan? So 9:05, balik tayo. So dun sa pagre-register sa Cloud RF, meron lang yung registration, tapos merong question, parang what is the wavelength of this, and then after nyo maano yung wavelength, magkakaroon na kayo ng access, free access, no? Anong band? ilalagay. Gamitin mo natin 900 megahertz muna. Okay, so I'll see you 9:15. 9:05, sorry, 9:05. Which band has the longest wavelength? Ano sagot dyan? High frequency. HF. Ay, yun yung question. Filter kasi nila yan eh. Kung sino mag-access. So at least merong knowledge about radio frequency or RF. Tama ba yung sagot, Edgar? Sir Edgardo, tama po ba? Error. Error yung lumalabas. Tingnan na, dapat tama. Baka case sensitive lang dapat yung sagot, sir. Okay. Tingnan nyo lang po sa email. So mag-log out muna ako. Yan. So normally ganito makikita nyo sa Cloud RF. Ano? So punta lang kayo sa My Account. After that. So punta kayo sa My Account. Huwag kayo bibili ng plan. Okay. So free muna tayo. Test for free on the island of Ibiza sa Spain. And then pupunta tayo sa web interface. Okay. So dito tayo sa web interface. Okay. Pagka na-click nyo yung web interface, magbubukas na yung inyong RF, Cloud RF. Okay. And then pupunta kayo sa island of Ibiza. Okay. So sa Spain yan. Ito na yung party island sa ano. Sa Spain, no? Yan, parang Boracay type natin. Yan. Okay? Yan, okay. So I hope na-install nyo na yung ano. Nakagawa na kayo. Hindi na pa na-install. Nakagawa na kayo ng account. Sino dito nakagawa na ng account? Can you give a thumbs up kung nakagawa na kayo ng account? Na-access nyo na yung ganito? Meron kayong Cloud RF? 4, 7. How about the others? Lalo na sa mga first timer no na gagamit ng simulator. This is one of the good exercises para kayo matuto ng ano ng start for radio network planning. Yeah. So kasaan ito basic or fundamentals ito ng radio network planning, yung simulation. Although this is free, this is free. Pwede naman tayo mag-simulate sa Philippines kaso we need to purchase a subscription. Ang subscription cost is nasa 2,000 pesos but we will just use the free version. Kasi ganoon din naman, we can still do we can still use all the features of the software. Ang ano lang is nasa Ibiza. Now, if you want to do simulation sa Philippines and if you want to use it in your like for example, you're teaching some students and would like to use the Philippine map, you just need to purchase a subscription. I think it's 2,100 or 2,500 per month. Okay, and then there's a limited number of simulations that you can use. Okay? Okay, are you ready sa ating exercise for the simulation? Okay. All right, so pagpalitin ko kaya. Pagpapalitin natin. Okay, so on the right side of the screen, you can see the typical site solution that we are implementing in telecom. Okay, so in our session 1, you get familiar with the different parts of a cell site, okay, or a radio access network. Okay, so let's assume that this cell site is LTE. Okay, LTE. So we have this tower. Okay, meron tayong tower dito. So you have this tower. Okay, meron tayong tower. And then yung tower na gagamitin natin for this one is probably 50 meters. Okay. And then meron tayong mga panel antennas. Okay, so these are the directional antennas. Okay. And then meron tayong remote radio unit, 1800. And remote radio unit of 900. Okay, ayan. And we have these jumper cables. So connection from the antennas going to the remote radio unit. And then this fiber optic. And then you have this. Mute na lang po. Hindi ko mahanap. Hindi ko ma-unmute. Okay. Okay, so you have the remote radio unit. Okay, so these are the RRUs operating at like for example 1800 megahertz and 900 megahertz. And then the RRUs are connected to the baseband unit via fiber optic or CPRI cable, a common public radio interface. Okay. So in the simulation, actually, the components that we will consider basically is the antenna, the jumper cable, and the remote radio unit. We don't need to consider the baseband unit and the CPRI. And of course, the tower structure. Okay? So I will just put it here. Itong ano, no? Itong ating system so that you can still see, you can always see and refer dun sa ating gagawing simulation, no? Lalakihan ko lang ng konti ito. Okay. So kapag inopen natin yung Cloud RF, so you can see the site. Okay? So when you click this, so you can rename the site. Okay? So let's rename the site as like for example, Richard. Okay? Yan, 24 Richard Sector 1. Yan. Buuin na natin para 7 characters. Yan. Yan. So Sector 1. Richard Sector 1. So meaning, ito ay Sector 1. Okay? And then Open RAN network. Open RAN network. So you can just rename. Okay? So kapag na-rename nyo na siya, you will put the longitude and the latitude. Okay? The latitude and the longitude in decimal form. Okay? So when you zoom in, pagka nag-zoom in kayo, pwede nyo i-zoom in yan using your mouse. Yung meron tayong ano, no, yung bang scroll ng mouse. So zoom in nyo lang siya, scroll nyo lang yung mouse. Okay? So ngayon lalagay natin yung site natin is dito sa area na to. Okay? So anywhere you can put the site. Okay? So after putting the site, you will define what is the height of the AGL. Teka lang, unit lang natin. Yan. You will put the height, the antenna height. So meaning ito, no? Mula dito sa antenna center line or above ground level, above center line, pababa ng tower sa ground, yun yung antenna height natin. So in this example, we will just use a 30-meter antenna height. Okay? So 30 meters yung antenna height na gagamitin natin. Are you following me? Can I get a thumbs up? Just let me know, no, yung sa mga umahabol or sumasabay. Just let me know kung mabilis ba or hindi. No? Si Lotus is error. Which part nung nag-error? Error sa pagbukas? Okay, so si Edgar is nakakasunod password. Ano mo lang Lotus, check mo lang kung naka caps lock or case sensitive kasi yung ano nila. Yung sagot, no? And then just check dun sa email. Para mabuksan mo siya. Okay? Okay. So, shall I proceed sa next step? Okay, na-set na natin 30 meters yung height. Meron na tayong coordinates kung saan ilalagay. So basically kapag ka nagki-click ka, no, pag nagle-left click ka, lilipat yung ano, lilipat yung site mo, no. So avoid necessary clicks, left click sa inyong map kasi lilipat 'yan, no. Lumilipat 'yan. Tapos makikita niyo dito, your coordinates are changing as you click the location of the site. Okay? So be careful on clicking the left click. Okay. Ayan. Okay. So, ito na yung ating coordinates. So, ang ating antenna height is 30 meters. Okay. Now, we will proceed sa signal. Yan. So, signal level. So, ang gagamitin natin na frequency is, like for example, is magka 2100 megahertz muna tayo. 2100 megahertz. Okay. Yan, 2100 megahertz, yung frequency na gagamitin natin. So after creating the inputting the value of the frequency, pupunta tayo sa RF power. Okay, so yung RF power natin is typical. Ito yung radyo, no? Ano yung nilalabas na power ng radio. Okay. So let's just use like for example 40 watts. Yan. So taas natin yung power natin to 40 watts. Okay? Are you following me? Okay ba? So 2100 and then 40 watts. Then after that, we'll set the bandwidth. So gumamit lang muna tayo ng mga 10 megahertz na bandwidth. Okay? So yung bandwidth is yung bandwidth ng ating frequency. Okay? 10 megahertz na bandwidth. So ito na yung radio, no? We already set the parameters. Okay, ito yung basic parameters ng radio. So what is the center frequency? What is the power? And what is the bandwidth? So last week, I believe si Danny already shown to you dun sa accessing ng remote lab, no? Ina-access niya yung remote radio unit doon. You can see the ARFCN, EARFCN, or the band, and the power, and the bandwidth. So this is how we set the bandwidth naman sa radio network planning tool. Okay? Can I get a thumbs up before I proceed sa next step? Okay. How about the others? Paano makapasok sa map? Teka, lalabas kasi ako na. Punta ka dun sa sa web-based, sir? Teka lang, sorry, RF. Cloud RF. Pagka pumasok ka dun, sir, punta ka, lalagout ka lang, Eto, sir, punta ka sa my account. And then, punta ka sa web interface. Click mo tong web interface. Okay? Ayan. Okay. So, andito na tayo sa bandwidth. And then, next section is the feeder. Ayan. Okay. So, the feeder is this one. From the antenna going to the remote radio unit. Okay? From the antenna going to the remote radio unit. So, we will be using a coaxial type cable, particularly yung ating Andrew Hilliax LDF4 F458. So, this is the jumper cable, the 1/2 jumper cable. Okay, yung pinakamaliit. And then, gagamit tayo ng mga 2 meters lang. Okay, so slide nyo lang yung slider natin dito for coaxial length. Okay, okay. Ayan. So 2 meters lang yung coaxial length natin. So 2 meters to. Tapos Andrew Hilliax LDF4-58. So ito yung jumper cable natin. Okay, so pagka tinignan nyo yan sa pag tinignan nyo yan, yung Andrew Hilliax LDF4. Yes, ganito yan. Andrew Hilliax LDF4. Ito po yan, no? Yung anong yan, LDF4. Ganitong itsura niyan. Yung kable na yan. Ito yan. Okay? Ito yung kable na gagamitin natin. This is only just a cable, right? But we also need to use a connector. Okay? So pagka pupunta tayo sa connector, we will be using 2 connectors. Okay? So one connector here sa antenna and then another connector papunta sa RRU. Okay? Gets mo ba? Para sa setup ng feeder. Thumbs up please kung inyong nagigets or nasusundan before we proceed bago kayo maiwan. Kasi mahirap pag naiwan, Okay. So meron na tayong jumper cable length. So automatic po yung calculation. Okay, automatic yung calculation natin. So in the calculation, you can see the effective radiated power calculated already in watts and in dBm. And the effective isotropic, radiated power. Yan, so 60 watts. So mas mataas lang siya ng ng 2.1 dB. Yan. Okay, so yung efficiency ng antenna, you can see here, is good. So meaning, walang nasayang na power dun sa kable natin. Okay? So just imagine, for example, tataasan ko tong length ng kable natin. You can see, the more, the higher the number or the longer the cable that we put between the antenna and the RRU affects our efficiency. So meaning humihina yung effective isotropic radiated power natin dahil sa cable loss. Okay, so dito nakukumpute agad natin. So that's why we are, as much as possible, we are eliminating the use of long cables. Yan, para hindi nasasayang yung RF power natin. Doon lang sa cable. Okay? Ayan. Okay na tayo? Okay, so next, we'll set up the antenna. Okay, we'll set up the antenna. So when you click the antenna, ayan. So I'm not sure kung lahat kayo is meron ng default na antenna dito, no? So this is a default, meron naka-default diyan na OEM, na original equipment manufacturers half wave dipole, okay? Pero sa akin kasi meron na akong kumuha na ako sa sa browse sa natin sa database. So what you can do to find an antenna, so titingnan niyo lang yung antenna natin. If 2100 MHz yan, like this, so we need to have a high band antenna. But po efficiency nung sa akin 76.1% lang. Tingnan mo sir yung length nung coaxial cable. Kung 2 meters yan, Sir Ronel. And then yung power mo is ilan ba? Pa-double check lang po itong coaxial length. Dapat naka 2 meters ka lang. Okay? Ayan. So, saan? Tanong ni first, sir, ask lang po if ang pag-set po ng frequency is in reference po ng bandwidth niya. Yung bandwidth is independent sa frequency. Yan. Ang factor ng coordinates sa power, no, wala pong relationship yung coordinate sa power. 77.8%, 77.8 in mind. Tingnan ulit natin ano niyo lang sir, i-restart niyo nga po ulit yung software. Mag-log in, log out para ma-refresh lang yung yung software. Maganda lang kayo, mag-log in, log out lang. Baka nagbabag yung software lalo na kapag first time yung na-open. Tingnan niyo po kung naka-watts kayo or dBm. Dapat naka 40 watts. Pa-check lang po kung naka 40 watts. Check natin kung naka dBm ako. Ganun pa rin naman eh. Pero dapat naka watts lang kayo. And then 10 megahertz yung bandwidth natin. Yung clutter sir, wala pa po tayo dun sa efficiency. Hindi niya ma-effect yung efficiency. Kasi ito is dito pa lang pagbuga pa lang sa EIRP. Hindi pa natin siya kino-consider sa Hindi pa natin siya kino-consider Ma'am sa sa propagation. Wala pa po tayo sa propagation. Pa-restart na lang po nung software. Baka nagkaroon lang ng bug. Ganyan talaga pag free. Ayan, 1973. Ayan, okay? Tingnan nyo lang din po doon sa mamaya kasi sa natin sa signal level, kung ano yung level nyo ngayon. Pero mamaya pa yan, dito muna tayo. Okay, pa-restart muna nung software. Tingnan nyo kung magbabago. Hintayin ko kayo. 77.8 pa din. Wala ba nakaset na loss? Dito? 1.09. Okay. Okay, sige. Iyan na lang muna natin. Itignan muna natin Ituloy muna natin.